let's take a look at significant digits, or significant figures, or sig figs. So you might remember them from another class, and maybe you remember that there are rules. You follow rules and you get the right answer. You hope you remember the rules, and so on. But there's ideas behind the rules, and the ideas explain why the rules exist. And those ideas are really what's important. So let's take a look at that. So one aspect of science that really makes it powerful is that science, when it's done correctly, is very clear about what is known and what is not known. Or rather, science, when done correctly, is clear about how certain or how confident we are about a conclusion, and how uncertain we are about a conclusion. Science, when done well, communicates the limits of our knowledge. So what does this have to do with sig figs? Well, significant digits, or significant figures, are the numbers which are significant, the ones that are important, the ones that matter, the ones that we know. If I tell you that the textbook is 4.52 centimeters thick, that means I am telling you that I'm certain that a 4 belongs in the ones place, and a 5 belongs in the tenths place, and a 2 belongs in the hundredths place. But I don't know beyond that. Now, the number in the smallest decimal place is called the least significant digit. So that 2 here in the hundredths place, that's the least significant digit for this measurement. And when I tell you this, I'm saying I don't know anything about what numbers belong beyond the least significant digit. So I don't know what number belongs in the thousandths place or the 10,000ths place or past that. And so I don't report them. If I did report them, I'd be claiming to know more than I do. So the reported numbers that I give you, the 4.52, those numbers are considered significant. They're considered important because they communicate what I know. By saying 4.52 centimeters, I'm telling you that I know 3 digits. So there are 3 significant figures. Okay. Now, what about a piece of paper? And let's say I tell you that the piece of paper is 0.0504 centimeters thick. Well, let's see. The least significant digit is in the, tenths, hundredths, thousandths, in the 10,000ths place. So that 4 in the 10,000ths place, that's the least significant digit. And I'm saying we don't know anything about any smaller decimal places. And that 0 in the middle between the 5 and the 4, that is significant. It's reported. And so I'm telling you, I know that that's a 0 in that place. It's not a 6, it's not a 4, it's not a 9. It's a 0 that belongs there. And the 5 is also significant because I'm telling you that I know that that's the digit that belongs there. So it's important. It is significant. Now, what about these zeros at the beginning? Well, yeah, we know that 0 belongs there. You shouldn't have a 2 or a 5 or a 9. But are they significant? No. They're just holding the decimal place there, so we can write the number in this way. And if that's confusing, then rewrite the number in a different way. Rewrite it with scientific notation. If you did, it would be 5.04 times 10 to the minus 2 centimeters. And if you look at that, there's 3 digits reported. Yeah, there's the times 10 to the minus 2, but that's just telling you the decimal place. The 5, the 0, and the 4 are the significant digits. Well, how about if I tell you that the distance from the Earth to the Moon is 384 million meters? Okay, well, the 3, the 8, and the 4 are definitely significant because I'm telling you that they belong in those decimal places. But what about all those zeros at the end? Well, that depends. If I've written this and I'm trying to tell you that those zeros really belong there, that anyone who does very good measurements will find zeros in those decimal places, then yes, they are significant. But if those zeros are just there to keep the 3, the 8, and the 4 in the right decimal place, then they are not significant. So, again, it helps to write this in scientific notation for clarity. If we don't write it in scientific notation, then those zeros are ambiguous. We don't really know if they're significant or not. But in scientific notation, we would write that as 3.84 times 10 to the 8 meters, which has 3 sig figs. There are also numbers that are out there called pure numbers. Pure numbers are constants that show up in equations. So like the area of a triangle is 1/2 base times height, or v squared is equal to u squared plus 2as. The 1/2 in the triangle area equation is a pure number. It doesn't have any significant digits, or another way to think about it is it has an infinite number of significant digits. It's a perfect number. We know all of the digits. So like in v squared is equal to u squared plus 2as, we know that that 2 in the equation is an exact 2. Now, we don't write out 2.000000000000000. We just write out 2. But that's because it's assumed to be a pure number. It comes from pure math, not from measurements, and so you don't have to consider its significant digits.